Assalamu alaikum warahmatullah. Hi everyone. In this video we will be looking at another question for question 2 from the coverage of a grade 11 elite. So this question says let f be the function given by f of x equals x over square root of x squared minus 4. Part A, find the domain of f. When it says domain, it means all the x values accepted by the function. Yani we need to find the x values that will make the function undefined and exclude them. So if you look at this function, first of all, it's a rational function, so we need to exclude the zeros of the denominator. So what makes the denominator zero? We have x equals 2 and x equals minus 2. So these two values, they will make the denominator 0, so we'll exclude them. X cannot be 2 and x cannot be what? Negative 2. And also we have a square root in the denominator. So we need to make sure that what we have under the square root is not negative, right? So this needs to be more than 0. Let me just write it here. So for part A, you need to make sure that this amount here is positive, because the square root of any negative value is undefined, right? So we need to make sure that this quantity is positive. This quantity is positive and cannot be 0, because again, we don't want the denominator to be 0. So we need x squared minus 4 to be bigger than 0, okay? So this can be done by getting the 4 to the other side. So x squared is bigger than or equal to 4. And if we take the square root on both sides, that means the absolute value of x is bigger than 2. So what does that mean, that the absolute value of x is bigger than 2? It means that x can be bigger than 2, or x is smaller than negative 2. So you can write your answer like this, or you can write it as the absolute value of x should be bigger than 2. Okay, another way is by investigating the x-axis or the number line. We have this number line, okay, and we know that negative 2 and 2 are excluded, so these are excluded. Now look at the denominator, square root of which is square root of x squared minus 4. Now we need this amount under the square root to be what? To be positive, right? To be positive. If you choose a value between negative 2 and 2, like 0, okay, and if you substitute the 0 here, square root of 0 squared minus 4, it will be what? It will be negative. And if you choose a number bigger than 2, like 3 or 4 or 5, 3 squared is 9 minus 4 is 5. So the square root of 5 is accepted by the function. And if you choose, for example, negative 3 or whatever, a number smaller than minus 2, it will be positive as well. So all the x values smaller than minus 2 are accepted. All the x values bigger than 2 are accepted, but between negative 2 and 2 are rejected, because again they will make the quantity under the square root negative. So we can say that x is bigger than 2 from here, and here we would say that x is smaller than minus 2. Okay, so there are two methods to find the domain. Again, 2 and negative 2 are excluded because they will make the denominator 0. This is the first part. Now the second part is write an equation for each vertical asymptote to the graph of f. So for part B we already did it actually, but let's do it again here. F of x equals x over square root of x squared minus 4. Well, the vertical asymptote is the x values, or the x values that make the denominator 0. So what makes the denominator 0? Well, we have here x equals 2 and x equals minus 2. Those are the vertical asymptotes. So there are two vertical asymptotes at 2 and minus 2 because they will make the denominator 0. So two vertical asymptote is at x equals 2 and x equals minus 2. Now if we look at part C, this is find the horizontal asymptote to the graph. So we have to find the horizontal asymptote, you need to find the limit of the function as x approaches negative infinity, and you need to find it as x approaches positive infinity of the function, which is x over root of x squared minus 4, and this is x over square root of x squared minus 4. So you need to find what are these two limits equal. The first one, when x approaches negative infinity, it will be minus 1, and when x is equal to positive infinity, it will be 1. So there are two horizontal asymptotes. The first one at y equals minus 1 and at y equals 1. So horizontal asymptote at y equals negative 1 and at y equals 1. So there are two horizontal asymptotes, and again, as we discussed before, for horizontal asymptotes please use y equal, and for the vertical asymptotes use x equals. Okay, how did we get 1 and minus 1 for those limits? I know some of you were trying large values in the calculator when finding the limit at infinity. However, we can also just investigate this limit the way we did in the class. So we said that we can divide everything by x squared, for example, here, or we can factor out x squared from the denominator. We can just say that the minus 4 has no effect compared to x squared. That leaves you with square root of x squared, and the square root of x squared is absolute value of x, and the absolute value of x is the same as x for x goes to infinity, when x goes to infinity, and the absolute value of x will be minus x for x approaches negative infinity. That's why the first one is negative 1 and the second one is equal to 1. However, the answers are negative 1 and 1 here. So let's look at part D, which says find f prime of x. Again, we have f of x be x over f of x equals x over x root of x squared minus 4. Finding this derivative, or the derivative of this function, require the chain rule. So f prime of x equals, I like always to start with the denominator, right? The denominator squared. Now here, what do we write? We will write the denominator times the derivative of the numerator, which is 1, okay, minus the numerator, which is x, times the derivative of the denominator. Now the derivative of the denominator is going to be the derivative of what you have under the square root, which is 2x over 2 times the root itself, x squared minus 4. Okay, so let's simplify this. F prime of x will equal to root of x squared minus 4 times 1 will be the same, root of x squared minus 4. and then you have minus. Here what happens here, you will cancel this 2 with this 2, and this x times this x will be minus x squared, right? It will be minus x squared over square root of x squared minus 4 all over x squared minus 4, because this power cancels the square root. We need to simplify further, right? So what do you think? What is the next step? We've got to make the denominators the same, right? We have to make the denominators on the numerators and the numerator the same. I mean, there is 1 here, okay? So let's multiply here by root of x squared minus 4, and the same here times root of x squared minus 4. So if we do that, what happens? Let's see. So this is f prime of x will equal to root of x squared minus 4 times root of x squared minus 4 will be x squared minus 4, right? Over root of x squared minus 4 minus x squared over root of x squared minus 4 all over x squared minus 4. So this is simplifies to what? X squared minus 4, x squared minus 4 minus x squared. So this x squared minus this x squared, it will cancel. That leaves us with minus 4 over square root of x squared minus 4 all over x squared minus 4. And here we have a denominator of 1. So this is something called keep, change, flip. When you have a fraction divided by another fraction, you keep the first fraction, okay, and then you change the division into a multiplication, and then you flip the other ratio, the other fraction, 1 over x squared minus 4, right? And 1 minus 4 times 1 is negative 4 over what? I know this is quite long, but this is how it's done. So negative 4 times 1, it's negative 4, and here this is having this is having a power of 1, and this one is the x squared minus 4 to the power of 1 over 2, which is the same as the square root, times x squared minus 4 to the power of 1. And when you have the same base, you just need to, and when you are multiplying powers with the same base, like x squared minus 4, x squared minus 4, you just need to add the exponents. So minus 4 over, this is x squared minus 4, add the exponents half and 1, 3 over 2. So this is the f prime of x. This is the last question from the file of question 2 from the FRQ and the coverage. So follow the order of the questions: question 1, question 2, 3, and 4. There are few more, but they are not multi-part, so please solve them on your own. That's it. This is the 4th question. Again, let me just have a look at the file. There is question 5, it's just a single part. Question 6 is question 7. So they are not multi-part, so they have less number of marks on each. So please have a look at the rest of the questions and solve them. Good luck.